Today I'm going to be talking about the SubParse project that we've been working on. It is an automated module framework for malware analysis. It is built off of Python 3.8, Vue.js, and utilizes Docker in the backend for containerization. Today I'm going to be giving a brief overview of the installation process, a quick demo, and talking about different use cases for the project. Diving right into it, the current system that I'm using has already gone through the Docker installation process. It is a bit lengthy, it does take a few minutes, and just didn't want to waste the time on the demos. So if we jump right over into the Docker manager, we can see that it does require quite a few different containers. It does have Elastic for our backend, custom website, and utilizes Kafka for our messaging service for background processing. I'm currently sitting at the root directory of the project. This is where you can find the Docker compose files to actually build out the containers that are needed, as well as the Docker file for our custom container. We do have a parse directory as well as a viewer directory. The parser directory is where we'll be spending the time in the command line, and the viewer directory is used for our website. So if we go ahead and cd into the parser directory, we'll just go ahead and look at the files that are in there. We do have this subparse.py, which is our main parser file. So if we go ahead and look at the help output for that, we do offer quite a few different flags. There's the tacd, which is the sample directory that is used for the actual sample locations. We require that the sample is inside of its own folder. That way we can also use that same folder if the system was to be put into service mode, which allows it to watch that specific folder and say that you're on an engagement or you're analyzing a bunch of different malware or currently collecting some. You can just go ahead and drag and drop that file directly into the folder, and our system will go ahead and kick off its processing with what other arguments that you pass on the command line when you initially start the service. We do offer a TAC-R flag that allows you so that when you're developing your custom modules for the program, that you can very easily reset all the databases without having to completely rebuild out all the containers. There are Enrichers, which is the TAC-E flag. So the Enrichers allow for post-data processing to help enrich the data that has been collected on the samples. Those are generally file type independent, more of a generic enricher, so you can reach out to, say, abuse.ch or other malware places to help collect more data or do sample analytics across the current data that has been collected. There is the TAC-EU, which allows for the updating of enrichers. So say that you've already collected a lot of samples, you've already gone ahead and done the regular processing on them, and say that you're currently working on development of an enricher, or you want to check to see if there's been any new data, you can just use the TAC-E flag or the EU flag, and it will automatically go and repull all of the information from the underlying enrichers. There is a different verbosity flag. Today we're going to be using the debug option just so you can see a little bit more of the information being displayed and kind of what it's doing a little bit more in depth in the background. And then as stated, there is the TAC-S, which allows for service mode. Today we will not be kind of covering that. So diving a little bit further, this is the command line argument that I will be demoing today. We do have a directory which is demo samples, which is where all the samples are held. We're going to be using the TAC-E flag with the abuse enricher. as well as the TAC-V with the debug. The project currently right out of the box offers for the parsing of PE files, portable executable, as well as ELF files. The vast majority of malware are mainly in those two data types, as well as different enricher modules that come with the project. We have abuse.ch, and then there also is a CAPE. So CAPE allows for the sandboxing of malware that allows you to run it in a safe environment and collect more data. We won't be demoing that just because the processing with CAPE does take quite a while and a little bit too long for the demo. So we'll just go ahead and run this. As you can see, not every sample inside of that folder will be found on Malware Bazaar. You can see that with the errors that are being thrown. These samples, there's about 13 of them. We allow for batch submission into our database. Currently it's set at 10, but that allows for an analyst, while they're looking at large data sets, to be able to actually go look at the data and start manually going through things on the site while the rest of the background stuff is happening. The website now, if we just go ahead and refresh this, as you can see, there's quite a bit of information that gets displayed in the initial table. We can see the file name, the different file magic, file size. We do have a derived extension because, as you guys I'm sure are aware, there's not every malware that you find is going to have the same legitimate extension. As you can see, like even here, the original extension wasn't out, but we classified it as a text file based on the actual file magic from the headers. The enrichers, if the enricher is not able to actually process, say from example, these errors that we were seeing, the enricher will not get saved on the data. These two samples were able to be used by abuse.ch, so we can see that the actual enricher module is there. So let's go ahead and look at some of the other functionalities. We do have a search bar. This search bar is completely dynamic. It allows for type ahead completion. From a developer standpoint, you don't have to worry about implementing the type ahead completion. We actually generate that server side, which allows for easier streamlining of integration, as well as better collection of the actual keys. So when analyzing malware, you never know what type of keys or how far it's going to be nested, especially when working with a lot of different APIs. You don't know the data that's always going to get handed back. So we try to make this as dynamic as possible to help everybody investigate fun malware. So let's go ahead and look at the difference between using the abuse enricher and one that didn't use the abuse enricher. So let's go ahead and look at this initial ELF. As you can see, we get this general information. This general information is always going to be collected on samples, regardless of if a parser was able to analyze it or if enrichers were able to analyze it. This is done directly before any processing. So we can get the MD5 hash, which everything inside of here is pivotable. So if we click on it, we're able to say, and this MD5 hash. Same thing with any of the parser data as well as enrichers. It allows for quick filtering down of data. As you can see, it got put up at the very top for the search. So if we just search off of that, as you can see, we automatically get that specific result. So going back to that sample, we do have the ELF parser. There's a lot of different data that gets collected, version information. It goes through a bunch of different header information. We get the program header segments. We get different sections. And this is all stuff for malware analysts that would take quite a bit of time to manually go through. And as you see, it only took a few seconds for us to gather all of this data instead of having to manually go through everything. We get relocation data up above as dynamics. We even get notes about different build environments or anything that could have been left behind by the compiler or the developer. So let's scroll up to the top and we'll go look at this abuse CH. And so this is also the difference between the ELF parser and a PE. As you can see, the top one that we were looking at was an ELF, so now we have a different header here that says PE. We get different signatures, completely different set of data. We still do get imports and different code sections. All of this is pivotable as well. So say that you're going through some of this code section and you want to find other samples that might have a raw size of X hexadecimal. We'd be able to instantly have it added, or you can say or this MD5. We try to make it so that as an analyst, being able to view and track down other samples that could be alike is as simple as possible, trying to bring as much power as we can to the process. So this is the abuse enricher that we had ran. As you can see, that this sample itself was a dridex, so we are able to kind of narrow down what each sample is, maybe the family it's from. We can see that the country of origin was in Italy. The first scene, this was done by us, so this allows for information from abuse.ch to instantly get added as first seen by this specific sample was back in 2021. Last seen different information from them. We also do get the maliciousness level as being 100. Different threat levels. These are attributes that would be being done, changing files, especially when it comes to malware, being able to track down some of the same types of things. It's doing the same attributes, the same properties. It really does help narrow down maybe potential triages. And as you can see here, abuse.ch does have a triage for this. This would be great for blue teamers or purple teamers to be able to come in here with a sample they've just found, maybe see an instant triage link, being able to quickly fix whatever issue there is, especially when it comes to like incident response teams. This could be a huge help to them. As you can see, dridex again. And yeah, that's a lot of the data, a lot of different data. It can really depend on the file size. Everything is also sortable up here. So say that we just want to see no enrichers or whatnot. Same thing with text and file sizes and whatnot, allowing you to really get ingrained into the data. I know this is a little bit of a quick, brief overview. The true value of this would be a lot of kind of digging into different samples that the company or an individual is really interested about, and really being able to pivot and really examine samples for themselves. It allows for a lot of different classification, a lot of different information that could take especially on large data sets of malware, hours and hours to get, that can be done in a matter of a few moments. As far as potential use cases, this really brings the ability for analysts, blue team, purple team, incident response, to really have some true power behind their job and abilities, and being able to quickly build out their own custom integration with different samples, collecting different data that they might want to see when they're doing analytics on malware, being able to have their own data sets of maybe new and upcoming things. Maybe they are pulling different samples from URL house or something like that, being able to have kind of their own data feeds. Going into other things about the project, we also do offer a cape Enricher. We're not going to demo that today, but it does allow for even more data to be collected about the sample, allowing us to, using a messaging service, drop the sample directly into a sandbox, executing the sample for duration of time, collecting, network analysis. Maybe there's a different file that gets dropped, which then we can pull back out and rerun through the program. And we use a messaging service in that case to allow for the program to continue running. Then as CAPE finishes its termination, it will automatically pull those, all the data got back from the CAPE Enricher and the CAPE sandbox and instantly submit it into the databases in the back end, allowing the users and analysts to continue on investigating the information which our program collects while other data is still processing. Both modules and enrichers the parsers and enrichers can be easily created and extended. Both parsers and enrichers only require two things. One of them is a Python file, and the other one's a view. So say you are a developer interested in malware and want to look into some different novel stuff or help extend the project. Integration of new custom things is quite easy. Only takes a few moments. We're not going to dive into that as a demo, but that will be well documented inside of the GitHub. And so that was just kind of a quick overview of a use case, overview of the setup, and a quick demo. I hope you guys enjoyed this, and I hope that you guys find some value in the project. It's been a long time coming, and this would be great for the malware community and blue team, purple team, incident response people to really have in their arsenal to help quickly analyze new novel malware and help to triage things quicker and being able to dive down into the exact malware that they're starting to stumble across in their day-to-day jobs. Well, I hope everybody takes care, and thank you for listening to the presentation.